In our final video for this chapter and our semester, we're going to talk about Edwin Hubble, some of the discoveries that we've made about the nature of our universe, and we're going to try to better understand exactly what the Big Bang Theory is. We have made major progress with our knowledge about the universe since those early astronomers. Now we have cosmologists, people whose job's just to study our universe. And one of the things that is probably most important about our universe is how it started. And we've figured out something called the Big Bang Theory that describes the birth and the evolution and eventually the fate of our universe. But what makes the Big Bang Theory so unique, in my opinion, is that it was discovered by a Catholic priest. He was able to calculate the rate that we see galaxies expanding and work backwards in time until a point that all of this matter had to be at a singular point. And he just called this a ball of material. And this ball was supermassive. It is incredibly heavy and dense and hot. But something happened 13.8 billion years ago that caused this ball of super dense material to begin expanding. And it's going to start expanding out in all possible directions, in 360 degrees. So how do we know that the Big Bang Theory actually happened? No one was around 13.8 billion years ago. So how do we know? And one of these is due to something that's called the Doppler effect. If you've ever been in a car and there was a siren approaching you, whether it was an ambulance or a police car, when that siren is approaching you, it's going to have a different wavelength than it does when it is moving away from you. You might hear differences in the siren as that ambulance is getting closer to your car and then when it passes you. And this is all due to the Doppler effect. It's a change in wavelength due to motion of an object. So we see that when something is moving away from you, it's going to stretch that wavelength out. If we look at something on an electromagnetic spectrum, it's going to cause everything to shift towards the red end of the spectrum when something is moving away from you. On the other hand, you might hear a higher pitch of that siren when it's moving towards your car. That's because that movement towards forces the wavelength to become shorter. It's going to cause that electromagnetic spectrum of light to shift towards the blue end of the spectrum. So when we take images using some special technology of other galaxies, we can see that they're shifting towards the redder end of these electromagnetic spectrums, meaning that they're getting farther away from us, not closer. They're expanding outwards, just like the Big Bang Theory thought. So we see that most galaxies exhibit this red Doppler shift. They're getting farther away from us, so we're seeing that their electromagnetic spectrums are shifting closer to the redder end. But we see that some galaxies are moving away from us faster than others. There's not a set speed that they're moving. And we see that the galaxies that are farthest away from the Earth are moving away faster than the galaxies that are closer than us. So the galaxies that are farther away have a greater velocity or speed than the galaxies that are closer to Earth. And all of this was discovered in the 1900s by Edwin Hubble. You might have heard about his really famous telescope, the Hubble telescope. But one of the most important things that Hubble did for science was discovering Hubble's law. And this is that the speed of galaxies is proportional to their distance. The farther away it is, the faster it's expanding away from us. And all of these expanding universes are going to create these red shifts in our electromagnetic spectrum. While scientists were working on the Big Bang Theory, they had some predictions that they thought they would have to eventually find in order to prove the Big Bang Theory true. And they thought that as our universe continued to expand outwards, it's going to stretch those electromagnetic waves. And it's going to stretch them so much that they're going to become very long wavelength radio waves. And in 1965, we actually were able to finally detect these really long wavelength radio waves coming from other galaxies. And this is called cosmic background radiation. Now that we've found this in 1965, it's pretty solid proof that other galaxies are expanding away from us. And if we could work backwards throughout time, eventually all of those different galaxies would have been compressed into one small area before it started expanding outwards after the Big Bang. So if we know how our universe began and that it's currently expanding, we also want to know about the fate of our universe. And there are going to be two major possibilities for what's going to happen. The first is called the Big Chill. And we believe, or some scientists believe, that as the galaxies continue expanding away from each other, those stars are going to cool down and burn out. Eventually, we're going to expand so far, everything's going to be so far apart, that it's basically just going to freeze our universe. But the other possibility is the exact opposite, and it's called the Big Crunch. With this one, we're going to continue seeing expansion of our universe over time. But eventually, galaxy is going to overtake that expansion. It's going to start pulling all of that material closer to the center again, causing everything to collide and form yet another high-energy, high-density ball, very similar to what there was right before the Big Bang.